Hopefully. All right, so linear regression line of best fit, also known as the least squares regression line. And if I happen to say it real fast, LSRL, least squares regression line. It is, again, the line of, it's the linear equation that is created from the data, and we use it to make predictions. We are used to seeing a linear function in the format of y is equal to ax plus b. Technically, in this world of statistics, that y actually has a little hat on it. And then that's actually pronounced as y hat. The y with the little hat on there, it's pronounced y hat. That is our basically predicted y value. Is what are we predicting our answer to be based on what the data created this equation for? It's a predicted answer. It's not the actual, it's just a predicted y value based on the equation that was created. A is our slope. It is the slope of our regression line. B is the y-intercept. Back when you, I talked about this probably 2 months ago. Back when you guys were in middle school, typically what we did as 8th grade teachers had you guys had a set of data like dots on a scatter plot or whatever, and we said, all right, take your paper. This is what I used to do. I told my kids, take your paper, fold it diagonally to try to split as many of those dots in half. Unfold it, trace a line. And then what we did was for the slope, we just said, okay, let's do rise over run. Let's start over here and try to figure out a nice rise over run kind of slope. And that got us through the 8th grade TCAP questions about doing the line of best fit, is what we could have gotten away with. Now we're getting more precise in finding it. And so what we would typically say is another version of that from 8th grade was, you got your line, don't pick 2 points that are real close to each other on the line. Let's get 2 points a little bit further away, but still close to that diagonal line that you created. Now find the slope between those 2 points. And that was your slope of your regression equation. Well, there's a more complex version of creating the slope of this regression equation. The nice thing is we don't have to do it by hand. We're going to let the calculator do it for us. That's why we get to type the stuff into the table as we do things. X is our explanatory variable. It is our independent variable. Y is our response variable. And again, it's our predicted answer based on whatever X happened. So as a little reminder, I had you guys go into this, turn on the stat diagnostic feature. That's what I had you guys do right there. I had you turn that feature on. Otherwise, what happens is if you don't do that, that R value, that correlation coefficient I'm going to talk about here in a minute, won't be on the screen. The slope and the y-intercept will be there, but your correlation coefficient won't be there. So that's why we need to make sure that we turn on the stat diagnostic. And then, again, we don't talk about it as much, this coefficient of determination, but again, that is displayed on the screen. If some of you are taking stats next year with me in the honor stats, or dual stats, we'll talk about those things a little bit more, is what we'll do in those courses. But, you know, for end of course purposes, we don't have to talk about the coefficient of determination at R. So here's our equation. It says anthropologists use a linear model that relates femur length to height. The model allows an anthropologist to determine the height of an individual when only a partial skeleton, including the femur, is found. In this problem, we find the model for analyzing data on femur length and height for 8 males given in this table. So they asked us to find and graph a linear equation that models that data. So they want us to come up with the equation that does that. So with this in mind, our femur length is going to be our X variable. The height is going to be the Y variable. And so I'm going to go ahead and get my graphing calculator up here on the screen so you guys can see it as well. And let me do second plus 712, clear that screen, go back into mode, turn on the stat diagnostic. Ooh, Mr. Stevens. Stat diagnostic on. Boom. Oh, come on. There you go. There you go. Enter. That's on now. There we go. So now we're going to go into stat. Go into edit. Now, this is where we got to be careful. When we put our data in there, you got to make sure you pair up each x value with the corresponding y value. If you don't, it's going to come up with some totally different equation. So I'm going to carefully type in this first column in for x. I'm just going to go straight down it, okay? So I'll let you do the same on yours.
Wait, how do we get there?
Press stat, S-T-A-T, and then enter.
Oh.
Yep. All right, so let's see, 45.2. Remember, careful with the happy fingers. All right, good. I'm on line 9. I got 8 numbers in there. I think I got all those in right now. I'm going to do the next line to the heights, 178.5. All right, so I got my 8 numbers in there. I'm just going to pause a little susur for theater people. Pause for dramatic effect. And then in a moment, I'm going to walk you through on how to get the equation. I just want to make sure I give you a chance to type them in if you need to. All right, anybody need more time typing in the calculator? All right, here we go. So now with this in mind, and it's not a bad idea to press second mode to quit the screen. So if you hit second mode to quit the screen, okay? And then we're going to go back into stat, and we're going to go over to the calculate column, and we're going to do option number 4 where it says ln reg. All right, so ln reg ax plus b. That's the one we're going to use. And then we're going to press enter. And then we got to inform the calculator, well, where's your x variable? Where is your y variable? Well, we have it set up for x, L1 and L2, so we don't have to worry about that. Leave the frequency list blank. Leave it the way it is. We won't get fancy right now, but we can actually tell it to store the equation somewhere if we want to, but we won't worry about that right now. And then I'm going to go down to calculate, hit enter, and voila. Our y-hat equation. Our y-hat equation is, notice they give me the format in the very top, y equals ax plus b. So my slope, 1.8807x, and then plus 82.6497. 4 decimals are usually great. You just want to make sure you pay attention on the problems, how many decimal places they tell you to take it out to. All right? Usually they use the fancy words with the THs after it. The ones that make you spit when you say them. Okay? Remember, there's no such thing as a 1th. All right? That's tenths, hundredths, thousandths, 10,000ths. Okay? That's usually the furthest. I got mine out to the 10,000ths. So that's usually the first we have to go. So there's my equation. Now they ask me in part 2 here, part B, it says an anthropologist finds a femur of length 58. How tall was the person? Well, we have to remember that X was our femur. Y was our height. So that lets me know that I'm going to actually put in that equation what is the predicted height for a femur that was 58 centimeters long. So what is the predicted height for 58? So that's 1.8807 times 58 plus 82.6497. And that's what I'm going to type in to my calculator. I'm going to type in 1.8807 times 58. And then I'm going to hit plus 82.6497. Again, I don't have to worry about parentheses. I can if I want to put them around it. Calculator does, please excuse my dear Aunt Sally. Parentheses, exponents, multiplied by. So it's going to multiply the 2 numbers out front first. then it's going to add that answer 82 to that answer. So it's set up to do our order of operations. Again, if you like to have the parentheses around the multiplication stuff, more power to you. You can do that. We get here our predicted height is 191.7303, and it looks like centimeters. So that's our predicted height. Predicted height for femur of length 58 centimeters. All right, well, what do we use all the time? Inches, okay? So we're like, wow, that's great. I have no idea what that means in my world. That mean if I was in Canada, I know and understand what that is and stuff. Or if I was in Mexico or in England or somewhere, I know exactly what 191 centimeters would be. So what would that be for us here in America? Oh, well, let's see. I can just hit divide. Anybody know off the top of your head how many centimeters are in an inch? What'd you say? You're right. It's close to 2.5. It's like 2.54, if you want to get nerdy. So if I can divide that by 2.54 and hit enter, and we find out that that is approximately 75.48 inches. Now we can start thinking about, okay, what does that mean in feet and inches? So 75 inches. 6'3". All right. You figure 12 inches to a foot. So if you divide that by 12, you're going to get, it's going to go in there 6 times with, the 3, 3 and so forth. So, so you're looking at 6'3". So, pretty tall person. So, all right. Now we get to practice another one. And after we do this next one, I'll let you get ahead of me. Let you work on that. And go ahead and write down on the next problem. Let's find that R value. What is the R value? And we're going to talk about that too, just to remind you. We talked about it before, but just to remind you, what is the R value? And I'm gonna shut up and type all my stuff in there as well as we do it. Stat, enter. Remember, if you go to the top of the column header and hit clear and arrow down, it'll get rid of all the data real quick. Column header, hit clear, come back down. It'll get rid of the data. Here we go. Again, once you get your data in there, you're going back into stat, over to calculate, going down to option 4. Again, I'm going to leave it all alone. It all has it down there for L1 and L2, so I'm just going to arrow all the way down to calculate. Again, as we take a test on this later in the week, I will tell you what place value to round. And it'll be the same place value for both the slope and the y-intercept. I won't have you do like 2 different ones. Like sometimes big ideas would have you do like different things. It'll be doing the same decimal place for the whole thing. And if you feel good to do part B, go ahead and do part B. Again, I have mine up on the screen. I realize, hopefully I didn't have any happy fingers. Anybody get the same thing I got? All right, thumbs up, good. It's the hard part sometimes coming back from a break. We get rusty and doing things. I just wrote a bunch of lesson plans to try to get ahead of the game when the grandbaby comes along. So that way.
Have you put all the grades in?
Have I put all the grades in? I'm pretty darn sure I have. I'll double check today. They're due Thursday.
I still have two mastery checks that I took with you that one morning the week before spring break when I was in here, and I took like 3 that morning.
I'll take a peek. I'll take a peek. I'll be glad to do that. I tried to stay up with those pretty good. We will do a mastery check tomorrow when we come in. We'll do one of those. We'll get back in the habit of trying to get you those points. Easy points is what I call it. Is what I see. All right. So now, Mr. Stevens realized he wrote down what the R value. He wrote down the word R value. That's the correlation coefficient. Correlation coefficient. Remember the correlation coefficient, as we learned it earlier in the semester, it talked about the strength of our data. Is our line is it strong based on the data points that created it? Is it a strong linear relationship going on there? Mr. Stevens forgot to get it from the screen, so I'm going to go back and do my 1-bar stat again, or not my 1-bar, my linear regression again, and I'm also going to do one other thing here real quick. So I'm going to go back into stat, calc, linear regression, and what I'm going to do here before I hit enter, I'm going to go down to store regeq, and I'm going to tell it to put the equation in for y1. So I'm going to hit alpha trace, and I'm going to hit enter. And so what I'm going to have it do to make my life easier in case I get asked to do a bunch of other things is I'm going to tell it to take the slope and the y-intercept, and in y1, I'm going to have it go ahead and write the y equals mx plus b equation for me. Now the only difference is it's going to have a lot more decimal places than my food. It's going to take out probably 8 decimal places on each part. But if I want to use the calculator to do some quick calculations, storing it into y1 allows me to do some things real fast. And that's what I was going to show you guys here when they ask you to do multiple things of doing things. So I'm going to go through here, hit calculate. I'm going to grab that R value. R values has 0.9967. So earlier in the semester, we would classify that as being a strong, positive, linear relationship. Remember, we had earlier in the semester, we had a little number line that we used as a guideline. What were the values that the R value had to be between, always? -1 and 1. So your R value had to be between 1 and -1. -1.01 wasn't good. It had to be -1. All right. The closer you are to a -1 or a +1, the stronger that line is. Meaning it's probably almost like a perfectly nice diagonal line. So when you see our R value here of 0.9967, that's a pretty darn straight line, nice straight line. So when I go to graph it, I shouldn't see zigzags. I should see almost my dots in a nice little diagonal line. Is what I should. I see it's going up. It's a positive value, so I know my line should be going up from left to right. That's confirmed with my slope. My slope is a positive 4.8. So. Now, in case, let's graph it. Let's make sure we review how we graph it. So when we go to graph it, we're going to hit second y equals. And right now, our plot is turned off because we reset our calculator. So my plot 1 is off, so I'm going to hit enter. And I'm going to go hit enter on. The first picture we see is a scatter plot. That's what we see in that first one. And then I'm just going to, I'm not going to change everything. I have my X and Y's in the L1s and L2s accordingly. And so I want to tell it to graph it. So I'm going to hit graph and let it graph it. I don't see it. Then I remember that, hey, we had some big numbers here. So I'm going to do zoom. Zoom 9 is zoom statistic. Zoom 9. There we go. Zoom 9 is zoom statistics. And as we look at that line that it drew, and again, the only reason it drew that line is because I typed it in. I had to store the equation into y1, so it actually drew a line for me. But don't pretty much all those dots touch that line? Pretty darn good. And so that's a really good, strong, positive linear correlation going on there. Now we can start, we can start asking some questions of, hey, what would be the predicted heart rate? Or sorry, what is this? What are we doing? Chirping rate. Okay. Oh yeah, the chirping rate based off of the temperature. So what can we say in general? As the temperature got hotter, what happened with the chirping rate? Got bigger, didn't it? We think about the colder it was, the earlier ones that we put in there, the temperature was really cold. And then as it started getting hotter and hotter and hotter, then we saw the chirping rate was going faster, 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 faster. Okay? And does that make sense when we think about summertime? You know, as we get more into the heat of summer, we hear the crickets more. And a lot of the hotter days, we have the tendency to hear them a lot more in the afternoon and the evenings compared to the early mornings. Or those of you that like to stay after 3 a.m., you don't hear the crickets as much because it started getting cooler during that time frame. Okay? And so when I get up at 5 a.m., then they're usually not, they're usually asleep. They don't chirp that much. So yeah, we have a nice strong positive linear correlation going on there. Remember, correlation and relationship are the same words. They're like synonyms for each other. Correlation. All right. All right. Let me let you do the next one, and then we'll do one more together here, and then we'll kind of look at some correlations here real quick, and then we'll finish up with some 1-var stats for the last part. So, have we done 1-var stats before? That sound familiar, or is it because of spring break we don't remember anything? Yeah, spring break don't remember a thing? Okay. So, I don't blame you. When I was a kid in spring break, I did lesson plans all last week and watched TV at the same time, so. All right, again, let you guys get ahead of me. I'm going to try to catch up. Again, if you want to get practice putting that equation in there, when you get to that store reg EQ, press alpha trace, and then pick equation 1, and that's why it'll put it in equation 1. All right, so our y hat equation 6.4510x minus 0.15228. And I'm going to copy down my r value is 0.9503. That's still a nice strong. Now that's again strong. Now, technically on this one, we would say there's a strong negative correlation. Actually, no, sorry, a strong positive. My bad. Sorry, it's still positive. Your value of your slope. So since our slope is positive, then that's what we should be saying for our correlation. It matches. Sorry, I saw the B is negative, and option 8 has A equals or A minus BX or plus BX. So I was thinking the way I teach my other stats class. So we still have a strong positive correlation between the two things that are going on here. As the As the diameter increases, the age increases. That's what that's saying. Again, if you want to graph it, we got everything set up. So we can just hit graph and then hit zoom 9, and it focuses in on it. So still a nice, strong, positive correlation, but there is some gap. There is some gaps between the line and the actual thing. It didn't hit all of them perfectly nice like the other one is. Because the other one, again, was 0.99, so that was like hit a lot of dots. But that's still pretty good. That's still a strong positive correlation. As the diameter increased, the age increased of the trees. Okay. Last little bit. If we scroll down here, remember we had some estimating R values. We did this earlier in the semester. Here we can see a trend that we definitely would say this is positive. Now, I wouldn't say it's a 0.9. There's a lot of gap in there. So would it be reasonable to say maybe something like a 0.45, maybe up to a 0.6? Somewhere in there, there's enough variation, some gaps in there that we don't have a strong positive linear, but we do have a positive linear relationship. We may want to say the word moderate is usually the adjective. Usually we use weak, moderate, and strong are the three adjectives that get used. What can we, definitely say about the next picture? Yeah, definitely negative. I would say this is more, this is getting close to strong. So this one is that, this one, and you get the benefit of tagging some words together where we can say this is a moderately strong negative. Not many of the adjectives that we can say, can we pair them up together, but moderately strong usually gets paired together. As we do things, we wouldn't say moderately weak. We would say weak. We would say, moderate. But, moderately strong lets us know we're on that teeter-totter. I would say this is probably an R value of somewhere around like a 0.7 is probably what that is. Somewhere around that is for an R value. This one, what would we say? Yeah, I'd definitely say it's a weak negative. It's definitely a weak negative. Okay, definitely a weak negative. So if they gave me numbers to look at, I'm probably looking at like a negative, 0.3 to maybe a negative 0.5. Somewhere in there, somewhere between those is what I would say is okay. They're not going to give me a bunch, but they'll probably give me one like in that range, and then one that's like a high negative, like a 0.8, negative 0.8, and then give me some positives, or they'll give me a 0. Well, this one's definitely not 0 because we do see a trend. As the X increased, the Y decreased. Here's definitely, I would say, a strong positive. I'm anticipating like a 0.8 to about a 0.9, somewhere in there is what I'm anticipating for this one. If I was to guess, wouldn't surprise me if it was like a 0.92, something in the low 9s. That's a nice kind of tight line there. So, all right, next part here as we finish up. We use what's known as one var stats is what we use here. One variable statistic. One variable statistics. We use that to help us find the mean, the median. Now, it does not tell us the mode. It will not tell us what the mode is. Okay? The mode is one of those things you're going to have to eyeball. You're going to have to look. What do we know the mode always stood for when we learned it earlier in years? Yeah, the one that occurs the most, yeah. Okay? Now, you were always taught there was like one mode. Because that's all we had to worry about for 8th grade TCAP. Okay? We won't see really any mode questions on the end of course exam as 11th graders. My world, in my honors stats class, my AP stats class, my college stats class, we actually have things that we call multimodal. It can be bimodal, means you have two distinct peaks. It may not be they listen the same amount of times, but there's still these two distinct peaks when you look at your data. Multimodal means I have more than two. We use one var stats, so do me a favor. Let's get our calculator again. We'll do one or two of these, and then I'll wrap it up and let you guys do the homework and call it a day. So as I get my calculator, again, I am going to, I'm going to choose the easy way out, and I'm going to clear my stuff. Actually, it looks like it cleared it for me since I closed it. So I'm going to go back into Stat, go back into Edit. So on your calculators, if you want to clear out the columns, you can. Or if you want to go to an empty column, go to an empty column. I don't care. Let's type in our data into, I'm going to type it into L1. So I'm going to type in 64, 69, 72, 54, 89, 92, 54, and 32. Oops, I put two numbers in the same area. I didn't press enter. All right. The great thing about when you're doing one var stat stands for one variable statistics. It's what we use to find the mean, the median, the mode. Well, not mode. The mean, median with quartiles, Q1, Q2, Q3, the min and the max, those kind of things. We'll talk about those other ones a little bit more tomorrow, but it's going to give them to us on the screen here. It gives us the standard deviation as well. Remember when we did z-scores before the break? And we talked about standard deviations away from the mean. So when we have a set of data, we can calculate what that is based on the data, and every set of data has a different standard deviation. And so that's what this one variable statistic thing is going to do. It's going to give us the mean. It's going to tell us what the median is. It tells us what we call the 5-number summary. We're going to talk about that more tomorrow. And it also tells us the standard deviation. That's what it tells us. And again, we'll talk about the standard deviation stuff more tomorrow as we do things. So I'm going to go in here, press Stat, go to Calculate, and option number 1 is my one variable statistics. We don't have to worry about doing a 2 variable statistic thing. So we're just having to worry about the 1. Press Enter. Tell it what column your data is in. So if you're like me, had it in L1, leave it alone. Did anybody have it in a different column? All right. So if you did, change it. Go all the way down to leave your list blank. Go down to Calculate, hit Enter, and voila. X bar, that's my mean. X bar, my mean, is 65.75. Remember, in the old days, we would have added up all those numbers to divide by how many numbers we had. So we would have taken 64 plus 69 plus 72 plus 54 plus 89, 92, 54, 32. Add those up and then divide by, what is there, 8 numbers or 8? Yeah, so that's what it would have done. So now, if I scroll down, the word MED, there's my median. My median, it says, is 66.5. Now, using the calculator, it does everything for me. But when we learned when we were younger how to find the median, what did we have to do? Put it in order like how? Least to greatest, and then we found the one in the middle. If there was a tie, what did we have to do? There you go, add and divide by 2. So notice we had an even number of terms, 8. So it went ahead and added the 2 numbers in the middle after it put it in order. It said, okay, this number and this number are the 2 in the middle. I had to add them and divide by 2, and it gave us 66.5. Okay, to where we didn't have to go through and do it. All right, so it did all that for us. Okay, that's what's nice about using technology is it can speed up stuff a lot faster. Okay, now we will talk more tomorrow about some of those other things like the min, the Q1, the Q3, and the max. What I want to point out. Can I zoom in? There we go. Zoom in, Mr. Stevens. You see that line right there. The little fat RX. There's our standard deviation. There's our standard deviation. Remember, we had our z-score stuff and we talked about standard deviation. Remember, before the break, we said z-score is equal to the value minus the mean divided by the standard deviation. So we had that little symbol. So this one tells us when we do a one-var stat, it actually calculates the standard deviation for us, that little fat RX. Now there's 2 types of deviations that are up there. One's called the population deviation, the other one's called the sample. We will primarily be using the second one down, is what we'll be using for our answers. My stats classes, we use either one, and we have to pay attention to what are we talking about. That lets us know which one we're supposed to use. Just in my stat classes. But you guys will primarily use the bottom one is what we're going to be using if they ask for the standard deviation of the data values. Is we'll be using that bottom one. So we'll stop right here. You can practice some more of those other ones if you want. We're going to pick this up tomorrow with the mean, median, mode, and that stuff, and the standard deviation. If you go out, now your homework's different. Your homework's different today. It's not in big ideas. Go to Google Classroom, and this is pretty much for the rest of the semester. It's going to be this way. Go to Google Classroom. You'll see an activity that should go live that has you go out to Edge Elastic where we do our tests. All right, that's your homework for tonight. 20 problems. It asks about positive correlation, negative correlation. It asks you for the slope or the y-intercept, some of that linear regression stuff. It does not have the one-var stat on there. Okay, it's got 20 problems. And so that's your homework. From here on out, we'll probably be doing that for homework for what we're doing, because I just don't like the way Big Ideas does some of the things, the way they grade some of the things going forward. It's like real crazy. So I thought about it over the weekend. I'm like, from here on out, I think we're just going to do the Edge Elastic is what we're doing. Now that takes away I got like 2 attempts or 3 attempts to get a problem right. Okay, so take your time. All right. We're not supposed to highlight answers and then hit check and see which ones are wrong and right, and then go back and change it. We should be doing it differently. Okay. So, as always, if you got questions, let me know. Text me. Okay. Thanks, bud.